Good morning, student. Today we will begin with lecture number 16, unit number 4, bending stress and shear stress. Today we will solve two numericals. These are the formula which we have already seen it in our previous lecture. These are the formula to find bending moment for various cases. Question number 1. A timber beam is simply supported at ends have span of 6 meter. It carries a UDL of 12 kN per meter over entire span and a concentrated load of 10 kN at the midspan. If the bending stress in the material of the beam is not to exceed 8 Newton per mm square, design a suitable rectangular section of the beam. Take the depth twice the width. Bending stress is given, span 6 meter, depth is D is equal to depth of the beam, B width of the beam, D is twice the width, therefore D is equal to 2B, UDL small w 12 kN per meter, capital W concentrated load 10 kN, sigma B bending stress 8 Newton per mm square. Figure 1. Simply supported with UDL or entire span and a point load of 10 kN at center. We have a simply supported beam, AC 6 meter span, UDL 12 kN and a point load 10 kN at the center. Maximum bending moment is at center B, MB is equal to W, that is UDL small w L square divided by 8 plus capital W into L divided by 4. This is the cross section rectangle BD. Step 1. You have to find maximum bending moment. M is equal to maximum bending moment when load acts at center in case of simply supported beam. M is equal to W L square divided by 8 plus capital WL divided by 4. The formula is already given. Substitute the value. M is equal to 12 into 6 square divided by 8 plus 10 into 6 divided by 4. Moment is equal to 69 into 10 raised to 6 Newton mm. Solutions. Step 2. We have to find moment of inertia about its horizontal x-axis centroidal axis, that is moment of inertia about its neutral axis. We know neutral axis is half of depth d by 2. So INA is equal to BD cube by 12, which is equal to B into in bracket 2B divided by 2B raised to 3 divided by 12. Since D is equal to 2B, so I by solving we get is equal to 0.666 B raised to 4. 0.666 T raised to 4. Now here Ymax. What is Ymax? Ymax is nothing but distance from neutral axis to the topmost or bottommost layer of the cross section. So that is nothing. Ymax is equal to D divided by 2. Now D is nothing but 2B. So 2B divided by 2 is equal to B. So Ymax is equal to B. Step 3. We have to find B. From flexure formula we know M moment, maximum bending moment divided by I moment of inertia about neutral axis is equal to sigma bending stress divided by Y, that is distance from neutral axis. M is equal to sigma I divided by Y. We substitute the value. M 69 into 10 raised to 6 is equal to 8 into 0.666 B raised to 4 divided by B. By solving we get B is equal to 235. Then D is equal to twice B is nothing but 2 into 235, that is 470 mm. So design section is equal to 235 into 470 mm. Second question. A T-section beam having flange 180 mm wide and 20 mm thick and web 150 mm long and 20 mm thick carries UDL of 80 kN per meter over an effective span of 8 meter. Calculate the maximum bending stress. L is equal to 8 meter, small load UDL is equal to 80 kN per meter, flange is equal to 180 mm into 20 mm, web 150 mm into 20 mm. Find sigma B. The figure is given, simply support it with UDL or entire span. UDL is equal to W is equal to 80 kN. Next, this is the cross section. Cross section. Now we need to cross section. First of all, we have to find. First of all, to understand this is a T section. The top part is flange number 1, so its width 180, depth 20. Then below is its web, width 20 mm and depth D2 is equal to 150 mm. You have to first find neutral axis, that is it is centrally located, x-axis axis. To find neutral axis, we have to use what we have studied in applied mechanics, the formula A1 y1 plus A2 y2 divided by A1 plus A2, which we have solved it. So that we will see later. Now here you see YC. What is YC? X-axis is the neutral axis. From neutral axis, the distance of neutral axis is the topmost layer of the section YC. न्यूट्रल एक्सिस x-axis है, तो वहाँ से लेके तो जो टॉप का है, फ्लेंज का टॉप का लेयर है, वहाँ का डिस्टेंस. वैसे ही YT इज न्यूट्रल एक्सिस से लेके जो बॉटम मोस्ट है, यानी वेब का सबसे नीचे का जो पार्ट है, लेयर है, वहाँ तक का डिस्टेंस. सो YT इज इक्वल टू 121.36 mm. ये YT YC हमने कैलकुलेट किया है, यहाँ सिर्फ लिखे हैं हम, लेकिन आगे हमने कैसा फाइंड आउट किया वह हमने पता किया है. सबसे पहले ये x एक्सिस कहाँ आता है ये हमने पता किया. तो ये कैसा पता किया? A1 यानी फ्लेंज के एरिया A1 इंटू Y1 यानी फ्लेंज का जो सेंट्रॉइड है वहाँ से लेके नीचे तक का डिस्टेंस, दैट इज Y1. सो प्लस A2 Y2. A2 इज वेब की एरिया प्लस इंटू Y2 यानी वेब का जो सेंट्रॉइड है वहाँ से लेके नीचे तक की एरिया डिवाइडेड बाय A1 प्लस A2. ये आगे हमने सॉल्व किया, हम देखते हैं. आइए देखते हैं. So step 1, we have to find maximum bending moment. M is equal to WL square divided by 8. We substitute the value. We get M is equal to 1.25 into 10 raised to 9 Newton mm. Step. And then again here we have to find from the figure the neutral axis. We have to locate the neutral axis. Where is the neutral axis? Neutral axis is located at the centroid of T section. Centroid of T section. T section का हमको centroid पहले निकालना है. T section का centroid कहाँ है वो हमें फाइंड करना है. वह हमने ऑलरेडी पहले सीख चुका है कि कैसा फाइंड आउट करना है. ठीक है, मोमेंट ऑफ एरिया मेथड से ये फाइंड आउट करना है. A1 Y1 प्लस A2 Y2 डिवाइडेड बाय A1 प्लस A2. Okay, so from the figure it is given A1 is equal to 180 into 20, which is equal to 3600 mm square. Y1 is equal to 150 plus 20 divided by 2 is equal to 160 mm. A2 is equal to 20 into 150 is equal to 3000 mm square. Y2 is equal to 150 into 2 divided by 2, sorry, Y2 is equal to 150 divided by 2 is equal to 75 mm. So using the moment of area formula, y is equal to A1 Y1 plus A2 Y2 divided by A1 plus A2. Substitute the value, we get y is equal to 121 plus 36 mm. Next, step 2, we have to find moment of inertia. Moment of inertia is given as I is equal to Ix, that is moment of inertia about centroidal x-axis, that is equal to INA, that is moment of inertia passing through neutral axis, is equal to Ig1 plus A1 H1 square plus next bracket Ig2 plus A2 H2 square. Again Ix is equal to B1 D1 cube divided by 12 plus A1 H1 square bracket close plus bracket open B2 D2 cube divided by 12 plus A2 H2 square bracket close. Now this formula, this we have already studied in moment of inertia. यूनिट नंबर 1 में हम ये ऑलरेडी सीख चुके हैं कैसे निकालना है टी सेक्शन का, आई सेक्शन का, सारे अलग अलग सेक्शन का, ये ऑलरेडी हम सीख चुके हैं. ठीक है, तो ये वही रिपीट हो रहा है. मोमेंट ऑफ इनर्शिया निकालना है अबाउट सेंट्रोइडल एक्स एक्सिस. सो आई एक्स एक्स सब्सटीट्यूट द वैल्यू 180 into 20 cube divided by 12 plus 3600, this is area 1, into h1 square is in bracket 160 minus 121.36 whole bracket close whole square. Similarly plus second bracket, similarly 20 into 150 cube divided by 12 plus 3000 here is A2, then again bracket which is H2 square, that is 121.36 minus 75 whole square. You substitute the value and now we have to solve it. Solving it, we get R is equal to 17.566 into 10 raised to 6 mm raised to 4. So this is moment of inertia. Then we have to find maximum bending moment M, and we have to find the distance YC and YT. Maximum bending moment M is equal to WL square divided by 8. W is 80 into 10 raised to 3 into L square 8 square divided by 8. Moment is equal to 640 into 10 raised to 3 Newton mm. Now second we have to find YC. What is YC? It is the distance from neutral axis to the topmost layer of the section, यानी न्यूट्रल एक्सिस से टॉपमोस्ट लेयर ऑफ द सेक्शन वो डिस्टेंस YC है. तो कितना है YC? 170 minus 121.36 which is equal to 48.64 mm. 170 पूरी हाइट है सेक्शन की, वेब और फ्लेंज की हाइट, उसमें से न्यूट्रल एक्सिस की हाइट निकालते हैं. तो न्यूट्रल एक्सिस से लेके टॉप मोस्ट का लेयर का जो डिस्टेंस है वो पता चलता है. नेक्स्ट, डिस्टेंस फ्रॉम न्यूट्रल एक्सिस टू बॉटम मोस्ट लेयर सो बॉटम मोस्ट लेयर कितना है? डायरेक्टली न्यूट्रल एक्सिस से बॉटम मोस्ट लेयर दिया गया है ऑलरेडी कैलकुलेट करते टाइम पे 121.36 mm. 121.36 mm. Now find bending stress. We know the flexure formula, M divided by I is equal to sigma B divided by YC. Maximum bending stress in compression, sigma B is equal to M divided by in bracket I divided by YC bracket close. M is 640 into 10 raised to 3 into 48.64 divided by 17.566 into 10 raised to 6. Now yeah, moment is 640 into 10 raised to 3. I is 17.56 into 10 raised to 6. YC नीचे था तो YC एकदम न्यूमरेटर में आ जाएगा. YC is 48.64. Solving we get 1.7772 Newton per mm square. Next we have to find maximum bending stress in tension. same formula, on everything same except the yt change. So sigma b is equal to m divided by denominator complete bracket I divided by yt bracket close. We substitute the value. Sigma b is equal to 640 into 10 raised to 3 into yt ऊपर आ गया 121.36 divided by I, that is 17.566 into 10 raised to 6. Solving we get sigma b maximum bending stress in tension 4.42 Newton per mm square. अब टेंशन में मैक्सिमम बेंडिंग स्ट्रेस कितना था और कॉम्प्रेशन में कितना था, दोनों का कंपैरिजन हुआ है तो मैक्सिमम बेंडिंग स्ट्रेस इन टेंशन ज़्यादा है. सो आंसर इज मैक्सिमम बेंडिंग स्ट्रेस इन टेंशन इज 4.42 न्यूटन mm स्क्वायर. हमको दोनों में से जो बड़ा है वो मैक्सिमम बेंडिंग स्ट्रेस होगा. जो सबसे ज़्यादा मैक्सिमम बेंडिंग स्ट्रेस क्या है टेंशन में आया है यहाँ पे, तो टेंशन का आंसर हमने ले लिया है. सो आंसर मैक्सिमम बेंडिंग स्ट्रेस इन टेंशन इज 4.42 न्यूटन per mm square. That's for the day. Thank you, student. Thank you.